Hey friends, happy Sunday night. It is, oh my gosh, August 18th here on the East Coast of the US. My name is Whitney or Whit. I'm coming to you from Durham, North Carolina. We are working on a quant GMAT free prep hour this evening, kind of in theme with what I've been working on the last few times. If you've joined me, we've been working on strategies, focusing on things like plugging in our own numbers, working backwards from answer choices, and we're going to carry on with that same theme this evening. So I'll go ahead and get my screen shared with you. Tonight's plan is still the quantitative section, although some of this may apply in the data insight section, but a lot of this is going to show up more traditionally in the quant section of the test under the concept of maximization minimization problems. Yeah, so I am excited. We're going to jump right in. The goal is to recognize max min problems and start to think about how we want to attack them. And so I'm just going to stick a problem on the board. I'll set a timer coming your way. I'll cut us off at about the 2-ish minute mark. If you're here in the room with me, go ahead and send me a message privately when you think you've got your answer, and then we'll chat about it together. All right. That's about 2.5 minutes. If you haven't gotten me an answer yet, please start to get me a guess. So tonight's problem type is the really broad family of maximization and minimization. Um, Generally, these questions are of a story variety, although they may have limited, storiness to them. But the signal is going to be one of the more obvious. We'll have a signal that says something along the lines of what's the greatest, what's the least, what's the maximum, what's the minimum, what's the most, what's the highest, what's the least. So the question is asking for some extreme, some like end value, which means that there are multiple possible solutions. So the first thing we have to recognize with a max min problem is that this isn't a problem that we necessarily solve for a unique value for. And that's different than a lot of the quant problems we run into. Most quant problems, there is with max min problems, there isn't always an answer. Sometimes there are a variety of answers, and we are being asked to find one extreme. So for example, in this company H problem, company H has $4,000 and 180 pencils, and they're going to distribute these this money and these pencils evenly. I mean, the fact is that if company H had one employee and they gave that one employee and 180 pencils, that would be an even distribution. Or, right, so we can kind of catalog it, right? Like the number of employees here. If I had one employee, each $1,000, and each employee, in terms of pencils, would get 180 pencils. I could certainly have more employees than one, but part of what we're doing in a max min problem is we're trying to figure out what are our constraints? What are the rules that we're going to have to adhere to? Because we're looking for a pattern in a sense. So we're looking to find what are the sort of elements of the number of choices. There can't be an infinite number of choices potentially, right? And so what I'm looking for is what is my kind of array? Like what are the choices that I can choose from? And like what are the qualities that are kind of constraining those things? Now, another thing to keep in mind that's building on our last session that we did on working backwards is that often when we're asked to maximize or minimize, right, that's the answer choice itself. And so there's this element in max min problems that we want to consider, would it make sense in this case to test my answer choices? And just to go after them directly, like, could this be a possible number? So I'll just go with one more example set. Like I could see us having two employees where each employee would get $2,000 and each employee would get 90 pencils. Right? There are some limits. We're told that the dollar amount has to be an integer number of dollars, so I can't give people change. And we need an integer number of pencils, so I can't give people like, half a pencil. So I know as I start to kind of list through these numbers, well, it's got to be something that I could divide. In this case, the concept of division or divisibility or dividing among employees, dispersing evenly, is going to be my constraint, is divisibility. So I might use a combination of coming up with values on my own, or I might go straight to answer choices. It seems like I could have a lot, right? Like I could certainly do, I think both of these numbers I could divide by 10. Which is nice. That helps me skip over one of my numbers. Like if I had 10 people, they'd each get $400 and they'd each get 18 pencils. But I couldn't go up to like 100 people because I couldn't split the 180 pencils evenly. So I could just keep testing out numbers. But what I'd rather do is either kind of visualize the relationships, use the answer choices, right? Like visualize the relationships to come up with an answer on my own, or use my answer choices. So a couple of things I want to check, right? In order to divide by 9, I'd need to make sure that I can actually divide both of these numbers by 9. I mean, yes, I've already shown that I can exceed 9, right? I can get to 10. But I know that 4,000 is not divisible by 9. Does anybody know how I know that? Because I don't have a calculator for the quant section of the GMAT. So how am I going to know that 4,000 is not divisible by 9? It won't split up evenly. Would I know that? Yeah. So in order to know that something is divisible by 9, one of the fast ways to check is I add up the digits. So 4 plus 0 plus 0 plus 0. The sum of those would have to be divisible by 9. It's not in this case. And so I can't divide 4,000 by 9. And so 9's not going to work. 10 definitely works, but I'd like to see, could I divide these further? So is 4,000 divisible by 20? Well, yeah, it would be. And 2 would go into 400, 200 times. So with 20 employees, I could get $200 each. And if I did 180 over 20, kill my zeros, I could have 9 pencils each. So, all right, that takes B out. So I got C. What about 40? Well, I definitely know that 4,000 is divisible by 40 because the 4 goes into 400 100 times. The question is whether 180 is divisible by 40. Well, 4, I can divide both by 2. That would be 9 over 2, but 40 is not going to work. So then the question begs, right, since 40 isn't going to go into 180 evenly, check would be 180. I know 180 would go into 180. They'd each get one pencil. The question is whether 180 would go into 4,000. Cut them both in half. That's 200 over 9. I can't cut them both in half again, and 200 is not divisible by 3. And so 180 is not going to work. My max answer here is going to be C. Right? So this is an example of how I could go through and test my answer choices. Right? Which is I shouldn't say always, but is often a viable method for max-min problems. But how could I solve for this directly? Now that we're thinking about the fact that, okay, I need to divide, 4,000, like what number can I divide 4,000 by? That is also the biggest thing I can divide 180 by. And if we start to think of the world of divisibility, this is where we think factors. Yeah, I could start to get like GCF, greatest common factor. So if I take 4,000, that is 4 and 100. 100 would be a couple of tens. The 4s would be a couple of 2s. Each 10 would be a 2 and a 5, a 2 and a 5. If I then break down 180, 80, 18 and 10, there's another 2 and a 5. So I definitely know they have a 10 in common. 18 is going to have a 2 and a 9, and that's going to have some 3s. Now, if you haven't seen GCF in a while, or LCM, greatest common factor, least common multiple, a really slick way of solving these is to create a Venn diagram for your two numbers. So I'll put 4,000 on one side, I'll put 180 on the other. Now, what I'm going to put in the middle, and these have quite a few overlaps. So what I'm going to put in the middle are all of the numbers in which they overlap. So I know that I've got 2 2s and 1 5. So there's 2 2s and a 5. So I'm going to put those 2 2s and a 5 in the middle. And then I'm going to see what else I've got. I've got 2 2s and a 5 over here on the 4,000. And then I've got these 2 3s over here. The smallest number that both of these would multiply into would be what I would find if I multiplied all of 2 times 2 times 2 times 5 times 5 times 3 times 3. That's my LCM. My GCF, my greatest common factor, is what I get when I multiply through. So the biggest thing that could go into all of them is the 2, 2, 5, or 4 times 5, or 20. So we might see a min-max problem in the world of, like theory. So we're dealing with how much I can divide. What's my divisibility? How many factors can something have? Right? Like more theoretical. I also often encountering max min or these kind of like maximization minimization problems in a space where we're dealing with like fixed formula relationships. So let's try another. Give this one a go. And again, we'll spend about 2-ish minutes. All right. If you haven't yet, let's get me a guess. So again, we have this language of max or min or greatest or least, but this time we're given a fixed relationship. We've got like a total amount, right? A total revenue, if you will. And so if we think about the formula for total revenue, we should start there. Total revenue is, at least in its most, generic form, price times quantity. And we know some of these values. We know for sure the total revenue, right? So we know that that number is 6,450. And now we said that attendees at this dinner gave at least $85 each. So we don't know exactly how much everybody gave, but we do know what a minimum amount was. And I'm trying to maximize my quantity. So when we're dealing with a given relationship, a given equation, if you will, what we want to do first is figure out what are we meant to be maximizing or minimizing. Okay, so in this case, we're maximizing quantity given a fixed total revenue. So this number, total revenue, is fixed, right? This is our 6,450. This is the variable of interest that I'd like to maximize. So I'm going to look at every other variable and I'm going to try to ask myself, well, what do I do to those variables given this relationship in order to make this one really big? So over here, I have a product. Make, right? Like if I'm multiplying two numbers together, if I'm stuck with a fixed outcome, then in order to make one really big, I have to actually make the other one really small. So my target here is to therefore minimize the other value. So when you're doing max min around a formula or around some sort of equation, you're trying to say, okay, let me plug everything in that's given, that's fixed. Let me identify what am I going to be maximizing or minimizing. And now all of those flexible variables, what do I do to them? Do I make them big? Do I make them small? Do I make them close to zero? Like, what do I do to those values in order to max or min this one of interest? So I want to make my quantity big, which means I need to make my price as small as possible. Well, I was told at least 85. So the minimum value of price here would be $85 for whatever this Q is. So I'll divide both sides by 85. And then I don't have a calculator. So we're looking at some means by which I can try and simplify as quickly as possible. Yeah. So lots of different ways we could get at this. One thing you might do, and if you haven't taken our foundations of math, like that can be a really good way to get you there. But for example, the number 8,500 is definitely divisible by 85, right? That number is definitely divisible by 85. The question is, to get down to 6,540, what would I have to subtract? So what's another way of writing 6,450 as 8,500 minus something? Right. And so this trick, this would be 2,000, right? I can take it down by like $2,050. So I can start to do sort of a subtraction game. So first I've got 8,500. You could also just do long division, but I just hate it. So we're just going to play with some numbers for a minute. I'm going to subtract off then whatever this 2,050 is. So I could do another, right? 850. So if I did like 850 and 850, that's 1,700, right? So I've got this like 1,700 over here. I'm close. Plus 350. All of that divided by 85. So this piece right here, first I'm going to have 100 people. but then I'm going to subtract off the first 10, another 10. So I'll subtract off 20. To do with this 350 over 85. And so I'm going to look for something that's pretty close. And so each, like if I double 85, again, that's 160. So 160. So if I've got 160 doubled again, that's 320. So at 320, I've got this little sort of like grouping here, right? That's another 4 people. I can't, so this would be 10 and 10 and 4. So I've got my 100 minus 24, like this extra junk over here. That's not like a full person. And so I can't actually, like, I can't account for this last person. And so I would have to only be able to have 100 minus 25, 24 and some change. So I have to go all the way down to 75. Now, of course, if you want, you can sit here and divide these numbers out. That's perfectly acceptable. Look for things that they're both divisible by, like 5, right? And so you'd find each of these divided by 5. So we'll kind of put these up for you. So same thing if I'm looking for 6450 divided by and 85 both divided by 5. So if I've got 6,500 minus 50 over 5, 5 goes into 65 13 times, right? 10 times is 50 and then another 3. So 6,500 divided by 5 is going to be 1,300 minus another 10. So that's, if I divide 6,450 by 5, I've got our 1,290. If I divide 85, that's 50 plus 35 over 5. So that's 10 plus 7, right? So 85 divided by 5 is 17. And then we're having to kind of go in on that math again. So you may look at some longhand multiplication or what have you, but we end up with a number, just like on the other one, that's going to be about 75 point. And so the maximum, like the maximum number of people who could have attended was 75, where some of them have to give a little bit more money. So I will say the new GMAT is requiring us to do a lot more longhand computation. And so if you haven't attended our Foundations of Math Computations lesson, I'm going to strongly encourage you to. We also have a lesson I did maybe last year about quick computations that can help you with some of those as well. Okay, let's take a look at a slightly more complicated formula. Math, not so bad, but slightly more complicated formula. Let's give this one a go. All right, if you have not given so what is the relationship here? I've got average, right? Where if I remind myself of the formula, average is sum divided by the number of terms. But then I also incorporate this number of median. So I've got 6 numbers. Median is a place. It's not a formula. It's a location in the set. So for example, if I were to 1, 2, 3, 4, 5, 6 numbers, if I were to add these numbers all up to each other, and I was to divide by 6, that would equal 18. That's my average. N, meaning right here, the halfway, right, the numbers is 16. I want, so if I made this the biggest number and this the smallest, I want to minimize this number. I want to make that number as small as humanly possible. So to make this number small, and I'm going to kind of rewrite this a little bit. So I'm going to add these 6 numbers. 1, 2. Okay, so I got 1, 2, 3, 4, 5, 6. Has to be 6 times 18. And I'm trying to make this thing really small. What I need to do all the as big as possible. Now I have some limitations, right? Because this one's a little weird, right? Like, especially around my median, if I want to make this number big, the biggest I can make this number would be the same as my largest, right? So let's say we're going to call this L for my largest number. So if I want to make this thing as big as possible, it doesn't say that they're different numbers. So I could make this number also the same size as the largest. I'm going to make these 2 numbers to make them really big, like, because these 2 numbers are about to be held because of my median. Right. So whatever these 2 are going to be kind of stuck at this like 16 point in the middle somehow. I want to try and make these 2 numbers as big as possible. So however small I make this number, like if I make this number small, these numbers have to be, they can't be any bigger than that. Or like I can't make them any bigger. And so what I might do, and you have a couple of options, you could start creating a bunch of other variables. But what we could do is try 2 different extreme cases. One would be the case where these 2 numbers really just are the same as the median. So I make both of these numbers 16, which then means I make these numbers 16. Times 16 plus 2L equals 6 times 18. Now, before I do anything, I'm going to cut all these numbers in half to make my life easier. 4 times 8, L equals 6 times 9. And then 6 times 9 is, 54 minus 8 times 4, 24, right? 32, excuse me. So I could conceivably make this number 22. So I know my answer can't be A, B, or C, right? So I definitely could get to 22. The other extreme, right? So one extreme would be to make numbers both like right at the median. But remember, however big I make one, the other one has to go small. So the other extreme in here would be to say, okay, let me also make this one big, which would mean making this one the same size as whatever the largest is. But now I have to use the fact that this missing number, and I'm going to make all these the same, by the way. All of these are going to be the same size. Whatever x is, x plus L over 2 is 16. Or in other words, x plus L is 32, or L is, or x is, excuse me, is 32 minus L. Right? I end up in this kind of like weird, but now things are going to start canceling out. Because if I try to replace all of these, all my L's are going to disappear and I'm not going to be able to solve. Which means I'm going to get a situation that doesn't exist. So when you start to like, okay, make it really big one way or make it really big the other way, either you'll get two different answers, you'll pick the bigger one, or you'll end up in a situation like this where it's like, well, okay, if I try to make these all as big as possible and these as small as possible, I actually end up running into an error, like where I can't do it. It's not possible. And so, right, the smallest possible value I can make this thing is, right, or at least from that first test, it would be 22. Now, we could, though, because this is such a visual solution, right, because this is why sometimes algebraic solutions are kind of a pain. What I could do is try to imagine, all right, here are my three scenarios. Right, let's see how small I could go. Or here are my scenarios, excuse me, 6 numbers. I know that the sum of these 6 numbers, right? So the average is, the sum is 6 times 18. But we can also think about like the average is like the weighted middle. And so if my average is 18, could I make this number 19? So if I made this number 19, and I need my average to be 18, but I need my median, right, in here to be 16. If I were to make this number 19, in order for my average to be 18, let's say I had each one of these 19s, that would mean, like, if all of these were 19, the only way to get my average to be 18 would be if all of these numbers were 17. And that wouldn't be allowed. So 19 won't work. If I were to try 20, I could try and do the same thing. I need my average to be 18. So for every 20, I'd need like a 16 on the other side to put 18 in the middle. But I need my actual median to be 16, not my, right? Like I need my median to be 16. So even if I were to try and make all these other ones really big, I still like couldn't get to of 16, right? A median and an average of 16. Because I couldn't make, let's say, all of these numbers 16. I couldn't keep those numbers being 16. And still get to an average of 18. Because each one of these is coming in -2. I don't have enough up here to over. And so this is where we get to, I could try it again, kind of plug through. Just erase them. To get a 21 down here, if I try to make this thing as small as 21, each one of these is, this is 3 over my average. So if I do some more down here, this is like 3 over my average. So let's say I have like a 16. This is 2 under, 2 under, 2 under. That wouldn't work. If I could make this 17 and 15, This would be up 1. This is 3 under my average. And so even if I made these as big as possible, right? Each of these is 3 under my average. This won't average out, right? This only 7 above with 9 below. I won't get an average of 18 here. So the lowest I can make this is 22. And the way I do it is just like we found when we tested it before. So if this is 22, I'm up 4 on my average. So if I kept this going up 4 on my average, I could make this, as big as possible. If this is up 4 on my average, I need to come down 4 on my average. So 14, or sorry, not a negative, but like a 14 down here. But I need to switch this number, not to 22, because that wouldn't work. I can't make it work. The only way I can make it work is if the median themselves. Right, so a -2, a -2, and then kept these all as -2s. And so our answer would be 22. Easier to solve as we actually just like kind of plug in max min, right? So we did kind of a really weird and complicated one together. Let's try one that's a little, same idea, same structure, but I want you to try one on your own. So give this one a go. There we go. It could be like testing the numbers if we wanted to work with the answer choices, but I think the more effective approach, and we'll see it on this problem as well, is trying to think about like, how am I going to adjust the number? So you are sort of testing, but in like an adjusting kind of way. Mm-hmm. Like what do I need to do to each of these unknown numbers? Do I make it bigger? Do I make it smaller? And what does it mean to make it bigger or smaller? You have not yet. Hit me with an answer. I think you'll find that this one's a little bit more simplistic than the previous one, which is good. Again, we're dealing with average, we're dealing with median. So I've got 5 numbers. The nice thing this time is that they're actually telling us what one of those values actually is. If I were to add these 5 numbers up, then divide by 5, the answer would be 56. So it's going to be 5 times 56. The median is 60. I'm going to make this the lowest and this is the highest. And the question is asking, what is the greatest value for the smallest one, for the lowest number? So I want to make this number as big as possible. So think about the fact that I have to add all of these numbers together. And this one I want to make really, really big. What do I need to do to the other 3 numbers that I haven't assigned yet? What would I do to those? Big or small? Yeah, I need to make the rest of them small. This is the lowest number. What's the smallest I can make this number? Could I make it equal to L? 2 numbers be the same number? No, you're exactly right. It says 5 balls are selected in which each ball is printed with a different number. So this number is going to have to be at minimum 1 more than whatever this was. So if this number was like 49, this number would have to be 50. Same thing here. I can make these only so small as the median. I can't bump past that median. And so 60, the next smallest number would be 61. And the next smallest number would be 62. That's the smallest I can make those. So I'm now going to add 2L plus 1 plus 3 times, or 60 plus 61 plus 62. So I'm going to go 3 times 60 plus 3, these extra ones, equals 5 times 56. Now, one of the things you can do when you've got ugly numbers like this that you're multiplying, another little trick. So I'm going to finish over here for a second. This is 2L plus the 3 plus the 1 is 4. The 3 times the 6 is 180. Make my 5 into a 10 by pulling a 2 out of the 56. Right? Because 56 is the same as 2 times 28, 25 for the 50, and then 3 more for the 6. So 28, 2 times 28. And so I'm going to take this 2 and multiply it by the 5. This is going to be the same as 10 times 28. So over here, I have 280, 2L plus 4. Subtract the 180. So 2L plus 4 equals 100. And then I'm going to divide everything by 2 first. So L plus 2 equals 50. And therefore, L equals 48. Is what we're doing is we're trying to kind of play these levers of max min and then be ready to do some creative multiplying and dividing to deal with computation without a calculator. So we identified the relationship. We found what values were fixed. In this case, the fixed values were the 60 and the 5 times 56. We identified what we wanted to max or min. And then we looked at what direction do I need to move the remaining unknown things. So let's try one more. We'll give this one a go. All right, how did this one feel? Did it feel like you were able to sort of apply some of the steps from the earlier question? Fingers crossed. Okay, so I have a sort of similar kind of setup. It's not quite average, but I've got $450 that's being donated by 25 people. And 15, there's this first 15 people. And then there's another 9 people. And then there's this like last person. And I want to know how to really maximize what this, we'll call this the last person donated. Well, again, if this is all a sum, if I'm going to maximize what this person donated, I'm going to minimize what everybody else donated. So these 15 employees donated at least $12, but less than 19. Well, I'm trying to minimize this number. So I'm going to make them $12 each. That's as small as I can make them. And these last 9 donated at least $19. So they're going to be $19 each. So now I will add these people up. I've got my 450 is 15 times 12 plus 19 times 9 plus this person. So some additional tricks. We'll keep the 450. I'm going to exchange a 2. I'm going to give 2 out of the 12 to the 15 to make that 30 times 6. I'm going to change 19 and make it 20 minus 1 times 9. And then plus L. So over here, 6 times 3 is 18. I got 180. Plus 9 times 2 is 180 minus 9 plus L. So I've got my 450 equals 360 minus 9 plus L. So I'm going to add 9 to both sides. This is 459 equals 360 plus L. And to get from 360 up to 459, or I can subtract it. So 459 minus 360. Another trick you can use to make numbers kind of clean. So this is another one you can learn in that computation lesson. In order to make this bottom number something easier to subtract, up 40. I'm going to slide 360 up to 400. So I'm going to take this number up 400. But to keep their distance from each other the same, I need to slide 459 up as well. So I'm going to slide it up 40. And so 459 becomes 499. And so what is 499 minus 400? It's B99. Nice, y'all. All right. Well, maximization, minimization, not the most common question on the test. So I definitely don't want you kind of like panicking, but I want you to be able to look for the words of like greatest and least, max, min, most, and start to investigate. Okay, I could use the answer choices, but I can also build the system. And for a lot of these problems, actually building the system is the fastest way to solve them. So set up the equation, set up the relationship, identify what pieces are fixed. Then, right, identify the pieces that are fixed, find what it is that you're making big or small, and identify what do I do to everything else. Please come hang out with us. We have all kinds of free study resources. You can come to our manhattanprep.com GMAT /free and attend more of these free prep hours. You can also attend a session 1 of any of our classes of our full 9-week courses for free. So sign up, come hang out with us, come learn more quant and verbal and data insights. Yeah, we're here to help. Have a wonderful rest of your night. It was a pleasure to get to hang out with all of y'all. Take care. Thanks so much.